Hello guys, welcome back to the portal. So this is lesson number 2 continued. Okay, so it's still part of lesson number 2. So we are still on neutralization and hydrolysis. Okay, so we have concluded the last video. Excuse me, we have concluded the last video with hydrolysis examples. Okay, so in order for me to continue to other points of hydrolysis, I have to go back to neutralization. Okay, so now if I have acid, if I say I have strong acid, I add it to what? To a strong base, okay. So now the reaction is not going to have double arrows, it's going to have one forward arrow. Okay, so so to get what? Salt plus water. Okay, remember that I said hydrolysis, it is the reverse of neutralization. So in this case, strong acid and a strong base, it's only one way reaction, so forward reaction, so there's no reversible, meaning we cannot have hydrolysis of a salt that resulted from a strong acid and a strong base, because this reaction is irreversible. Okay, so and then now what if I also take strong acid and and try to react it with a weak base? Here, yes, I will have a reversible reaction, which is what I will have, yes, salt plus water. Okay, so here there's hydrolysis, so there's neutralization, and then this side there's what? Hydrolysis. Okay, so this side, the first one, there's no hydrolysis here, only neutralization, in the first reaction, and then the second one, there's neutralization and there's hydrolysis. Okay, so the third one, if I say a weak acid, I mix it with what? I mix it with a strong base. Okay, weak acid and a strong base. Here there's also a reversible reaction. So now the result is what? The salt plus water. Okay, so also here there's hydrolysis. Okay, and then in here we have what? Neutralization. So the forward reaction is neutralization, the reverse reaction is hydrolysis. Okay, so here the forward reaction is a neutralization, there is no reverse reaction on the first one. Okay guys, so now from the three reactions. Okay, so now if you can check this, let me talk about the pH. Okay, The pH we know even from previous grades that it tells us about the acidity or the alkalinity of a solution. Okay, so now let me take a nice green, okay, that is visible. So a strong acid, it has what, a pH of what, of less than 7. Okay, all acids have pH of less than 7. Okay, weak acid also pH of less than 7. What about a base? A base has a pH of greater than 7. Okay, doesn't matter if it's weak or strong, but the pH is greater than 7 for a base. Also here, pH greater than 7. Okay, so now remember from the definition of a strong acid. A strong acid is a substance which ionizes completely in water to form high concentration of what? Of hydronium ion. And the base, it dissociates completely in water to form high concentration of what? Of hydroxide. So now, during a reaction of acid and base, so we will have, when both the acid and the base, they've completely reacted, the final is solution, the final solution, the pH of the final solution will be what? It will be is equals to what? It will be equal to 7, which is neutral, because the solution will be neither acidic nor basic, because both the acid and the base, they produce high concentration, and then so now the pH of the final solution will be what? Will be 7. So now, what about the second reaction? Let me use a different color for the other side. Okay, let me use this nice blue. Okay, so here the pH will be what? Will be equals to 7. The pH of the solution after we've added a strong acid to a strong base, and at equivalence point, okay, it's where the moles of the acid have completely reacted with moles of the base, so the pH will be equals to 7. So if we check reaction number 2, we have a strong acid and a weak base. Remember, strong acids ionize completely, and a weak base dissociate or ionize incompletely. So we will have more moles as compared more moles of acid as compared to the moles of the base. So even at the completion of the reaction, the base will not have ionized or dissociated fully, because it's a weak base. Okay, so but the acid will ionize completely, and then now the smaller amount of the moles of a base will react with whatever moles of acid, and then there will be excess moles of acid that are remaining inside the reaction, uh, inside the solution. So the final pH will be what? Will be acidic, which is greater than 7. Why? Because moles of acid will tell us that the solution is acidic, and acidic means pH is less than 7. Okay, so now on number 3, the weak acid and a strong base. So notice that the weak acid ionize incompletely, and the strong base dissociate completely. So we'll have more moles of the base as compared to the moles of the acid. Okay, so at the end of the reaction, we'll still have the moles of the base in excess, meaning that our pH will be what? Will be alkaline, or basic, which is what? Greater than 7. Okay, so now even if you take it in reverse, you talk about hydrolysis. So hydrolysis of a salt that resulted from a reaction of a strong acid and a weak base, right? The final solution, the pH of the final solution will be what? Will be less than 7. Okay, it will be less than 7, this one. So the solution of a salt that is resulted from a strong acid and weak base will give a final solution of pH of less than 7. Why? Because of we will have more moles of what? Of the acid. And also here, the third one, the hydrolysis of a salt which resulted from the reaction of a strong base and a weak acid will result in a solution which is alkaline, which has a pH of greater than 7. Okay, so now you'll notice that the hydrolysis of a salt that has resulted from reaction of stronger acid and stronger base does not happen, because reaction neutralization reaction of strong acid and strong base is irreversible. Okay, so it's not going to happen, that one. So now okay, hydrolysis, okay, guidelines. Okay, so now so hydrolysis of a salt from of a salt resulted from a reaction of a strong acid and a strong base. Strong base does not take place. Okay, does not take place. Does not take place. Okay, and then the pH of the final solution will be equal to 7. Okay, so will be equal to 7. So now but then now what about hydrolysis of a salt that has resulted from a reaction of a weak acid plus a strong base. Okay, so we'll have a pH of what? Of greater than 7. Yeah, so we'll have a solution of pH greater than 7. Okay, now for example, we have what? We have hydrolysis of sodium ethanoate. Okay, sodium oxalate and sodium carbonate. Okay, so sodium sodium ethanoate, that sodium oxalate, uh, and what? In sodium carbonate and sodium carbonate. So if there's hydrolysis of these salts, the final pH of the solution is going to be what? Greater than 7. Okay, let's do one example. So let's take the hydrolysis of sodium ethanoate. So hydrolysis is the salt plus what? Plus water, right? So now remember, it is reversible. Okay, so this salt plus water, it will form what? It will form back the ethanoic acid plus sodium hydroxide, So now if you can check here, we have what? We have a weak acid. Here we have what? A strong base. Okay, so now the hydrolysis that results from the reaction of a weak acid and a strong base will have a solution that is greater than 7. How? Because this weak acid, it has pH of less than 7, right? And this sodium hydroxide has pH of greater than 7. But this weak acid ionizes incompletely, and this sodium hydroxide dissociate completely. So now we can tell that the reaction forms hydroxide. The hydrolysis of sodium ethanoate forms hydroxide ions, and hydroxide ions are what? Are basic or alkaline, and its pH is what? Is greater than 7. So if we were to remove the sodium, because it seems like it's a spectator ion, so we would have CH3COO minus plus water, giving us what? Giving us CH3COOH plus hydroxide ions. So if you are asked what is the pH of the solution when sodium ethanoate is dissolved in water, what will the pH of the solution? Will be greater, less than, or equals to 7. What you will say? You will say the pH of the solution is what? Is greater than 7. Why? Because there is formation of hydroxide ion. That's it. So when they say explain with an 8 of an equation, this is what you write, and then plus OH minus. So, and then why will the pH be greater than 7? Because there's a formation of hydroxide ion, and we know that hydroxide ion, it's basic. Okay, so here we can see that, oh, from the first equation you can explain that because the hydrolysis of the sodium ethanoate results in formation of a strong base, which is sodium hydroxide. Okay, then that's it. So now what about the hydrolysis? This one will be obvious to you. Hydrolysis of a salt resulting from a strong acid and weak base, resulting from a strong acid plus weak base. Okay, so it will have a pH of what? Of less than 7. Okay, why is that? Okay, let's take uh, we can take one example. So one example is this, an example of ammonium chloride. So example, ammonium chloride. So I've given this examples to my learners. So I have noticed that many, actually it was a question from a previous question paper, and then I've noticed that many of them could not answer this question because they did not understand how to balance the charges. Okay, but they were able to see that hydrolysis is addition of water. So please, if you still struggle with charges, check the previous video that I have made, which is lesson number 2. So this is the part 2 of lesson number 2. So now ammonium chloride, it's something like this. Ammonium chloride. Okay, so the hydrolysis of ammonium chloride. So what happens is this: if ammonium chloride is added to water, it will dissociate to form what? To form NH4 plus and what? Plus Cl minus. Okay, so now this NH4 plus ions, these ammonium ions, they will be ionized. They will ionize in water. Okay, so to form what? To form hydronium ion plus ammonia. Okay, to form hydronium ion plus ammonia. Okay, so now and then the overall reaction, it will be Cl NH4 plus Cl minus, giving us hydronium plus NH3 plus Cl minus. But notice that Cl minus is a spectator ion, so it does not really take part in the reaction, so it cancels out. So this is the hydrolysis of salt resulting from a strong acid and what? And a weak base. So which strong acid is that? It's when the strong acid is HCl, and then the weak base, the weak base is what? Is ammonia. So we can see that here there's formation of what? Of hydronium ion. So and then now for hydronium ion tells us about the acidic. Okay, so now we can conclude that if they ask you, will the pH of the final solution be greater than 7, equals to 7, or less than 7, what do you say? It's less than 7. Why? Because this the hydrolysis, for example, that one question, it was asking about hydrolysis of ammonium. So you continue and say the hydrolysis of ammonium results in what? In formation of hydronium ion. And then we know that hydronium ion tells us about acidity, and acidity is less than what? It's less than 7. Okay, guys. Yes. Okay, so now I'd like to give you an exercise. Okay, so you will do this exercise. Okay, is based on uh, this hydrolysis. Okay, so now uh, it says that it's asking will the hydrolysis of sodium oxalate will the hydrolysis of sodium oxalate result in solution of pH that is uh, greater than 7, less than 7, or equal to 7, or equal to 7? It's a question. After answering the question, give a reason for the answer. So this question, typically it is asked like this. So here they will give you 1 mark, here they will give you 2 marks. So what do you say here? Now pause the video and try to answer the question. Okay, you are done. So what is the solution to this? The solution to this is what? Is when I say solution now, I'm talking about correction, okay? So is that the answer is what? This we have to look at that this is what the salt of that result from a reaction of strong acid and weak base, or weak base and strong acid. Between those two, we have to look at that. So oxalate, it is a negative ion that comes from oxalic, and oxalic is oxalic acid, which is a weak acid. So we can tell that, oh, oxalic acid, it is a weak acid. And sodium comes from the sodium hydroxide, which is a strong base, right? So now here we can tell that, okay, so oh, here I didn't give a reason for the answer with an aid of an equation. Okay, with an aid of an equation. Yes, this is the full equation. So now what do you do? So with hydrolysis of what? Of a salt resulted from a weak acid and what? And a strong base. So we will say pH is greater than 7, because what wins is going to win the stronger substance, which is the stronger base, right? So the acid is a weaker acid, so it's not going to win. So the strong base will win. So but why? Explain using an equation. Okay, so we have to check, oh, sodium oxalate. You have to know how sodium oxalate is. Okay, sodium oxalate, so it's something like this, okay, plus water. So forward, reverse. So it must give us what? Oxalic acid plus what? Sodium hydroxide. Okay, remember that this is a diprotic acid. So for every diprotic acid, for every 1 mole of diprotic acid, 2 moles of uh, sodium hydroxide are required. Okay, so now if there are 2 moles of hydroxide that are required, therefore 2 molecules of water will form when a reaction takes place. So the forward reaction is what? Is hydrolysis. Hydrolysis. Then the reverse is what? Is neutralization. Okay, so now if you check uh, the forward one, which is the hydrolysis, so it is a reaction of a salt with water, so to give us a weak acid plus what? A strong base. Okay, so what will you say? You will say that uh, hydrolysis of blah blah blah, which is the salt that they've given you, uh, results in formation of hydroxide ions. Hydroxide ions. Okay, why do I say hydroxide ions? If you can check here, we have 2 sodium atoms. Even here we have 2 sodium atoms. So sodium, when this sodium oxalate goes into water, it will separate from this oxalate ion. So now it serves as a spectator ion. Okay, so now meaning here we'll have 2 OH minus. So hydrolysis of this salt results in formation of hydroxide ions. That is why the solution is a pH greater than 7. Okay guys, so let's talk about the conjugate acid base pairs. Okay, so this one I think it should have its video so that it can be shorter and we can make more examples and make this video shorter, because remember it is a part 2 of lesson 2. Okay, thank you guys. Don't forget to like, share and subscribe. Ciao.